Before I hopefully creep you out, let's make sure we know the basics about simulations in general. I promise to not make this too complicated, but we need to consider how simulations work at all. So, at first, we make a model of something from the real world, something that captures the important aspects and essence of whatever it is that we want to simulate about this object. For example, say we had a tire and we want to simulate how it would bounce under certain conditions. How do we actually simulate that? Typically, we mathematically model the object based on physics. All that means is that we look at the physics of the thing and try to write maths equation that represents it. So given some starting conditions, we will have a set of equations that tells us what we expect to see if we flick the tire off of some wall with a given amount of force. Let's see what the most simplistic modeling would look like. As you can see, the tire does fall off the edge and land on the ground, but it seems off. This is not reality, so how can we improve on this? Well, we could model the physics better and maybe even incorporate some bounds. Once we do that and reset the simulation and flick that tire off again, we do see a different outcome. Now, this is not the real world either, but even this crude simulation does mimic the real world rather well. The key idea is that the more things about the tire and the environment we model, the better our simulation gets. Of course, there are more to simulations than just this, but I think if you have been able to follow me so far, you get the gist of it. Every simulation, no matter how complicated, that you will ever come across is essentially trying to do something like this. We can study the world around us and come up with mathematical equations that represents the things in it. It can be the collision of objects, the motion of fluids, orbits of heavenly bodies, anything really. In principle, as long as it exists in reality, we can capture its essence in the form of equations and solve those equations to simulate them virtually. Do a good enough job and you end up with a virtual reality of your own. Now let me guide you to the creepy part of this. If you paid enough attention, you must have noticed that underlying all these fancy simulations are just mathematics. That same simple equation that simulated the drop of the ball in the beginning of this video does not require computers for us to solve it. In fact, high schoolers around the globe solve that equation by hand to pass their basic physics exams. In more complex simulations, we resort to the use of computers to reduce labor and the time required. Reason being that the computers excel at computing a human lifetime worth of computations in a flash. With that in mind, let me walk you through where things get very interesting. Brains are physical objects, and just like all other physical things, they're slaves to whatever physical laws exist in this physical universe. So in principle, you should be able to write down the equations representing every part of a given brain. That would give you the mathematical model for the brain. Remember how we don't need computers? Yes. You could simply pull out your notebook and your pen and start solving those equations by hand. It will be exceedingly laborious and take up too much time, but in principle, you could do it. And just like in our tire simulation, the input was a flick, some sort of force, and the output was the dynamics of the tire. For your brain simulation on paper, the input could be a question and the output a response. So you can start with your question and the mathematical model, solve the equations on your notebook, and by the end of it, you will get a response, an actual response. You can keep giving it inputs and solving the equations, and it will keep responding. So you can essentially have a conversation with it just the way you would with a person. This raises some questions. For example, who is it that's talking to you? For a person, you can at least try to localize the being inside the brain of that person. But where would you say that this entity that is conversing with you is localized? Where do they exist? On what plane do they exist? Anyway, that's it for today, and I hope you enjoyed this creepy thing that I came across some random place years ago. I can't even remember where I heard it the first time around, but hope you enjoyed it. I don't really fully understand how to put a YouTube video together, record things, do the animations, and put them all together and make them seem flawless. I don't understand that yet. However, I know that in time I will understand all of it and be able to make a much better presentation. So please like and subscribe, unless you don't want to. In which case, I don't know. I guess we'll see how far you go in life with that kind of attitude.